It is running, isn't it?
All right. Study Guide, Test 3. I've pointed out several things you need to know already, especially when it comes to alpha beta stuff. We just started getting into that. We'll get into that more on Wednesday, but just looking at the study guide, I'm just going to go down through it, make sure we get it covered. Number 1 on the study guide, central nervous system and peripheral nervous system consist of brain and spinal cord for the central nervous system, and everything outside the brain and spinal cord is your peripheral nervous system. So this is a simple one. It's about the only simple one on here, but this is the simple one. Number 2, the neuron is the functional unit. We already knew that one, I hope. Functional unit of the nervous system. Number 3, what do Schwann cells and oligodendrocytes have in common? Well, they both produce myelin. They both produce myelin. Schwann cells are in the peripheral nervous system, and oligodendrocytes are in the central nervous system. 4 is just a statement. Sodium influx triggers an action potential. That's just a true statement. That's all that is. Number 5, action potentials versus EPSPs. There's several differences. The easy ones to remember is action potentials are all or none. EPSPs summate. Now, can an EPSP summate to an all or none? Can they summate to threshold and cause an all or none? That's my question. It's a simple yes or no answer. Huh?
I said yeah.
Yeah, it can. I mean, we used the example of little Johnny up here, didn't we?
Oh, yeah.
We got an action, didn't we? Somatic versus autonomic. Somatic's voluntary, and it's skeletal muscle, is your example. Autonomic is involuntary, things you don't have to think about for them to work. Number 7, what promotes and what inhibits axonal regeneration? This was in chapter 7. We talked about this very early, and we said that for, first of all, the chances of a nerve regenerating itself is pretty slim. If it were to regenerate itself, there has to be 3 things in place. Number 1, it has to have a myelin sheath. It has to have a myelin sheath. Number 2, we have to have or find a way to promote nerve growth factors. We have to promote nerve growth factors. And number 3, we have to inhibit the inhibitory proteins. We have to inhibit the inhibitory proteins. That takes out all negatives. We've got a place to go, we're promoting growth, and we're reducing any roadblocks that might be in the way. Number 8, be familiar with excitatory and inhibitory neurotransmitters. They listed a couple examples of each in the book. Excitatory, we talked about acetylcholine. That's excitatory. They use glutamic acid as another excitatory neurotransmitter. Inhibitory, they listed GABA, which stands for gamma aminobutyric acid. GABA is much easier to write than the rest of that. And they use glycine. Both are inhibitory. So, like muscles, these neurotransmitters come antagonistically. For every excitatory neurotransmitter that promotes the biceps from contracting, we have to have an inhibitory to stop the triceps from contracting, right? Does that make sense? Okay. Number 9, endogenous opioids. What do they do and what inhibits? Well, they're your natural painkillers. That's what they are. Endorphins, dynorphins, and enkephalins are what they're called. They're your natural analgesics or natural painkillers. They call them opioids because their effects are very similar to opium in the body. What inhibits them, in our study with remember the pregnant rat that was in labor? And we gave this rat a shot of reversal drug. Their reversal drug in the book was naloxone. That's just one kind. There's other kinds out there, but that's the one they use. So that's the inhibitor. If we blocked it, the rat was in a lot more pain than we really wanted her to be, I guess. But it was better to do that with a rat than a female human, correct? That would have been bad. Number 10, purpose of neuropeptide Y. Now you're going to want to go read about that in the book because they tell you several things. One of the main things we pointed out is it promotes appetite, and we said that leptin should inhibit it. That's one thing we mentioned. At the very beginning where it talks about neuropeptide Y, they list 2 or 3 others. I would go look those up. Number 11, define spatial summation. This is just a basic definition. Spatial summations is convergence of many neurons on a single postsynaptic cell. Convergence of many neurons on a single postsynaptic cell. And then purpose of nitric oxide, number 12. Our main purpose here is a vasodilator, dilation of blood vessels. Vaso as in V-A-S-O. I see a lot of people spell that B-A-S-O, vasodilator. That's not it. It's vasodilator. 13, purpose of the 4 lobes of the cerebrum, the corpus callosum, and the cerebellum. This is straight off your lab. So your cerebellum, 4 lobes, we had frontal, which dealt with personality, language, memory. Anything else? I think that pretty much covered it, didn't it? Your parietal dealt with somatosensory and somesthetics responses, which is touch, pressure, pain. Occipital vision, temporal hearing. So there's your 4 lobes of the cerebrum, which we've already had that test, so you should have those a little bit fresh on your mind, hopefully. The corpus callosum is where information crosses over from left to right hemisphere and vice versa. So again, on the lab test. And the cerebellum, what is it? Yes, you do.
Is it the whole part or is that cerebral?
The whole,
Okay.
no, the cerebellum is the balance and coordination. No, the cerebrum's the largest part of the brain. Yeah. Cerebellum is balance and coordination. It's the cauliflower shape that sits back there on top of the brain stem. Number 14, comparison of Wernicke's and Broca's. So we need to know some information about these two. If you recall, the Broca's area, this person could had difficulty speaking, could understand it, spoken or written, but difficulty speaking, so they was very reluctant to speak. That's Broca's. Now, Wernicke's area is where words are organized into a sentence. And a person with damage to Wernicke's area didn't understand spoken or written language, but they could speak a blue streak. It may or may not make any sense. It may be made up words or it could be real words, but there's no organization to what they say, so they call it a word salad. That's Wernicke's area. You probably wanna go in and read about the arcuate fasciculus, where it bridges the two. Well, there's one area there where all the words are brought in and then sent to Wernicke's. So I'd go in and review all that pretty close and just get a good understanding of that. I think in our book, it's page 214 and 215, I think. Number 15, the hippocampus. Ultimately, it's still long-term memory. The hippocampus is for long-term memory.
You said on factor number 14 on Wernicke's, you said that one was the one that was more permanent, right?
Yes, and that's a good point to point out. Wernicke's is a more permanent, and in one of those little side commentaries in your book, it states that, and I do ask that on the test. Wernicke's is much more permanent. It's the worst, put it that way. I'm glad you brought that up. 16, ablation of the limbic system may cause what? Well, let me go back to the story this question's based off of. In your text, they tell a story about monkeys. And the research was they noticed monkeys were scared to death of snakes. When they went in and ablated, ablation means surgical removal of, usually for research purposes. When they ablated the amygdala of the limbic system, these monkeys were now playing with snakes because the amygdala dealt directly with fear. It gave them a fear content. So ablation of the limbic system, and I generalized the question. If you took out the whole limbic system, you would take out the amygdala. Now the snakes have no fear. So to answer the question, it may cause lack of fear. Lack of fear. Number 17, cerebral dominance is an old term. They like cerebral lateralization more now, but that's just showing that one side, we favor one side more than the other. That's all it's talking about. If you're left-handed, you tend to be right hemisphere for 70% of people. If you're right-handed, you're left hemisphere, and that's for over 90% of people. So there's always an odd duck out there that doesn't fit the general criteria. 18, purpose of Pepez circuit. And it connects, it allows communication between the thalamus, hypothalamus, and limbic system. Thalamus, hypothalamus, and limbic system. It allows those to connect or communicate. Number 19. Epithalamus simply is where cerebral spinal fluid is produced. Cerebral spinal fluid is produced. Number 20. Hypothalamus. We could make quite a list here of things that it's involved in, so we just simply say it's involved in nearly everything. Many physiological functions. It'd be probably easier to list the things it's not involved in, which I'm not sure we'd have a list. So the evil thing for me to do is put that as an answer on each question. That would be evil, so I don't do that. But you could arguably put it as the answer on nearly every question. And you might get it if it's the answer most correct, right, Jennifer? Number 21, neurohypophysis. It is the posterior pituitary. Does it make any hormones? It only stores and secretes. It doesn't make any. What gland controls it? I heard that. Hypothalamus. When in doubt, but the hypothalamus. if you're not sure, put the hypothalamus. Everybody should say hypothalamus together. Hypothalamus, yeah. What do you think would happen to us if the hypothalamus just decided to quit?
Everything was clear.
You'd fall totally apart. If it's the housekeeping center, it deals with appetite, thirst, body temperature, of course, hunger, sleep, reproduction. That's just some of the things they listed in the book, so we'd fall apart, wouldn't we? Gotta have it. 22, the medulla oblongata. That would be the water boy's favorite component of the brain. What did it deal with? Medulla deals with what centers?
Breathing and
And we call those vital centers. Breathing, of course, respiratory center, cardiovascular center are the two main ones. But they call them in the book vital centers. Think about it. If the respiratory center quits working, is that vital to life? If the heart quits working, is that vital to life? That's why they call those, if we find breathing and we find a heart rate, those are vital signs, right? See how the medical field comes together so well. Reflex arc consists of, can you name the first step of the reflex arc? Receptor. Second step? Sensory takes it to the central nervous system, which is the third step, association, right? What's the fourth step? Motor back to the fifth step is effectors, which are either muscles or glands. That's gonna be your effectors. What starts it that's not part of it? A stimulus. A stimulus. We have receptor, sensory, association, motor, and effector. And a reflex arc can be as simple as a single synapse. I think in the lab they talk about the knee-jerk reflex. Have we done that one? We did that lab, 3.3 and 3.5. And in the lab they talk about, a little contradictory in some of their information, they talk about it may go to the lumbar region of the spinal cord, but in most cases that I've looked at, studied, and read, it's a single synapse in the knee area itself and never even goes to the spinal cord, and that's why it can respond as fast as it does. If it has to go to the spinal cord, then you have a much slower response. Although that's not very far, you wouldn't have the quick synaptic response that you do, so. Knee-jerk reflex is one of the simplest. Number 24, sympathetic versus parasympathetic. What's sympathetic for? Fight or flight. It's fast. It's survival. Name the things, name the systems we don't need in fight or flight. Digestion, reproduction, excretion. Of course, we'll point out in chapter 9, there are extreme conditions in excretion where you may be afraid and be all over yourself, but it could get worse than that. So when it comes to shunting of blood in the sympathetic system, we're going to shunt blood away from the skin, the viscera, which is going to lead into the digestive, excretory, reproductive systems, and we're going to promote it to the skeletal muscle, right? Heart's going to get its supply, brain always gets its supply, but we're going to promote to the skeletal muscle. All right, parasympathetic. What's its purpose in life?
Vegetative state.
Your mundane vegetative states. Doesn't get any lower than this. This is digesting. This is, if I can get off the couch, I'll go excrete in the bathroom, maybe. It's pretty bad if you ask your wife to bring you a urinal to to the couch, but I guess it does happen. So it's everyday mundane activities. Number 25. Examples of synergistic, complementary, synergistic, additive, and of course are antagonistic. There's a couple different places in the book it talks about these. Synergistic, complementary, one place they talk about follicle stimulating hormone and testosterone in males working together to give you spermatogenesis. And I think page 316, they use an example of estrogen, cortisol, prolactin, and oxytocin all working together to give us milk production. So those are synergistic, complementary. They're working together for a common goal. Synergistic additive would be one improving the other. This one's a no-brainer with epinephrine and norepinephrine. They always improve what the other one can do. Antagonistic's the same from day one. It's either insulin or glucagon, which is probably on test, was that on test 1 or 2? And the other one is PTH and calcitonin, right? PTH and calcitonin. 26. The one neurotransmitter that is released by all preganglionic fibers of both sympathetic and parasympathetic. Anybody want to take a shot at that? It's our most common example we use in class, and it's excitatory.
Endorphins.
No, those would kill pain. But that's exciting when pain's killed, so I can see where you got that. Anybody? Acetylcholine. See, you're sitting over there withholding information. You knew it all along. It is ACH, acetylcholine. Number 27, there's 12 pair of cranial, 31 pair of spinal nerves. I gotta throw one easy one in there for you. 12 pair of cranial, 31 pair of spinal. '28, Parkinson's is characterized by, what do they think here? Parkinson's is characterized by, what have we said all along? Degeneration of the dopaminergic neurons. That's it. '29 is kind of a lab question. Sulci are the valleys or mountains? They're the valleys. Gyri are the mountainous areas. They're together, they make the convolutions of the brain, which increase surface area. Number 30 is saltatory conduction. That's jumping from node of Ranvier to node of Ranvier. We can do that in a hurry when we have myelin sheaths. If it has myelin, it's faster, right? If it's thick with myelin, it's the fastest. What do we say, 225 miles per hour? If it's thin with myelin, still has speed, but it's not as fast as thick with myelin. Thin unmyelinated is the slowest. And then thick unmyelinated, and then thin myelinated, and then thick myelinated. That's the key. All right, 31, cable properties. Ability to conduct. That's what cable, when they reference cable properties in the book, they're referencing our ability to conduct electrical current, which at 225 miles per hour is not shabby. But if we compare it, our ability to conduct to copper wire is terrible. Somebody in some class made this statement and I wrote it down. They said it's sucky. whatever that means. It's bad, I guess. It sucks if it's bad, so we're not very good compared to copper wire, but we're good enough to kill ourselves. We stick ourselves in a lock socket, so it'll conduct enough. 32, myelin, increased conduction rate. We've known that from day one. I've said that from the day one lecture in chapter 7. Myelin is the key to speed. (33) The blood-brain barrier. What is the most abundant glial cell that makes up the blood-brain barrier? I'm sure they got the name after the dog on Jetsons. See, I'm trying to give you all kinds of clues here to remember this stuff.
I can't.
Oh, no.
Elroy was the boy.
Elroy was the boy.
I can't think of it like.
Astrocyte.
Astro.
Yeah, Astro was the dog.
That's what it was.
Astrocyte. You know it's time to retire when nobody knows what you're talking about. Non-shivering thermogenesis. What is it? Non-shivering thermogenesis. Genesis means origin of. We're trying to create heat here, aren't we? But we're doing it by burning of brown fat. That's what we're using, a stored source of energy. We're burning it. We're not to the point of shivering yet. That'll come next. But we're going to burn this fat to create energy to maintain body temperature. That's non-shivering thermogenesis. Burning of brown fat to create energy. What's the difference in brown fat and other forms of fat? We burn brown fat first. That's all I can tell you. I guess it's easier to break down. 35 simply says, well, I have several questions comparing somatic and autonomic. And somatic, simple. I mean, we had that right at the beginning on the study guide. That is skeletal muscle and it's voluntary. Autonomic is when you remember the cholinergic, adrenergic that we ended off with in chapter 9. I said if you hear the term cholinergic, you should think of 3 things. What are those 3 things you should remember when you hear cholinergic? At this point, this is the point you should go, oh, 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 oh.
Uses ACH.
ACH,
Preganglionic.
preganglionic,
And
parasympathetic. That's cholinergic. 3 things that go with adrenergic. Norepinephrine,
Postganglionic.
postganglionic,
And sympathetic.
and it's a sympathetic response. So there's some examples from autonomic, and number 36 is kind of one of those. Adrenergic versus cholinergic, we just covered that. Goosebumps are adrenergic. It's hair standing up on the back of your neck. You ever been that scared that you get goosebumps and hair stands up on the back of your neck and you just freak out?
Mm-hmm.
I knew this class had. One has. You're kicking in that sympathal-adrenal system. You're kicking in that fight or flight. I mean, alertness picks up, and it's like, holy smokes, what was that? Well, it was obviously in this part of the country, it had to be a Sasquatch, right? Don't you love that show? Y'all ever watch that show?
I watched it once or twice.
It's a waste of time. They're never going to see one. You know why? Because there's not one. Thank you very much. I have people calling me from other parts of the state. Y'all really have Sasquatches down there? No.
You go to Broken Bow, I really think they do have Sasquatch.
I know, but you know, they drink and smoke a lot down there.
Like, there's like a billion different convenience stores that sell all kinds of Sasquatch.
Oh, yeah,
They
it's-
have like their own Sasquatch
There's no need of
stores.
it. Well, what little town has their own Bigfoot festival every year?
Oh, yeah, it's.
Showground.
Honevy.
Yeah.
Yeah. I'm gonna turn my video camera off. I think we're done with this.